Welcome back, dear students. So in previous video we learned about synchronization. We learned that if a synchronized method is called over an object, then other threads cannot call same synchronized method. But to be very honest, that does not solve the problem of synchronization. Let us see a case. See here. In this example, we have got a queue, a class queue. This queue is having two methods. One is to get and another one is put. The concept is very simple. It's a queue in which we are going to put number. There will be two threads. One thread will put number by calling this put method in the queue, and another will call get method to get the value from the queue. So you can see here we have got a member variable n. Whenever get method is called, it is doing nothing, just displays got n with the current value of n, and it returns n. Right. Similarly, when put is called, it will actually receive a value here, and that value it is assigning to the member variable n, and then it simply displays what the new value has been put inside the queue. Right. So this queue object will be used by two threads. One thread is producer, this class, and another thread will be consumer, which is actually this class. Right. Now see what producer is doing. Producer creates an object of queue, the queue which we have just created, and then inside constructor it will receive an object of the queue and assign that object to the member variable queue, and then it creates a new thread with the name producer and it starts a thread. You know that when you start thread, actually its run method will be called. So obviously we are calling start on this. It means that this run method will be called, which is inside the producer. Now inside run we are doing nothing. We just say I equal to 0, and we indefinitely, this loop is indefinite, which will not end. We'll have to end it by interrupting it by pressing Ctrl C or by stopping the program. And this does nothing. This indefinitely puts q dot put I plus plus. It means every time it is going to put value of I. Initially 0, so it puts 0 and then increase by 1, then put 1, increase by 1, put 2, increase by 1, and so on. Right. So run method of producer thread is going to put new value inside the queue. Similarly, if you look at the consumer, it implements runnable. It has got the same queue as a member variable. Consumer will receive a queue as an argument, and then it does nothing. Queue is equal to this member variable queue, and then consumer is given as a thread name, and then we start. When you start, you know that this run method will be called, and this run method does nothing. This indefinitely queue dot get. It means calling this get method from the queue, which is doing nothing, which actually gives the latest value of n, which is actually the value in the queue. Right. Now see what we are doing in the main method. In the main method we say queue is equal to new queue. We are going to create object of this class, and we pass same object to both producer and consumer. You know that when their constructor is called, they are actually starting the thread. Right. Now you might assume that because we have these two methods, a synchronized method, and you might imagine that synchronized method will be called in complete accordance with the put and get, but not really, because if one thread has called a synchronized method, then another thread cannot call that synchronized method, but another thread, no one will stop it to call another synchronized method on the same object. It means that yes, when producer is in execution of put, no one can call put method, but no one will stop another thread to call the get method. It means that simultaneously both methods can be called. The resultantly, if consumer is faster than producer, then consumer might be consuming same value multiple times. Or in reverse situation, if producer is faster than consumer, then producer might be producing some values which are being missed by the consumer. So in any case, the synchronization will not prevail because one thread is faster than other, right? So just having synchronized method may not be sufficient to implement proper synchronization. Let's first see its output. When I run this program, you will see that I stop it because otherwise it will not stop automatically. When you see this program, you can see here put 0, then put 1, the put 2, put 3, 4, 5, 6, 7, 8, 9, 10, 11. The first time the consumer got the opportunity to run, by that time producer has already put 11 values. Obviously this will get only latest value. It means all those values from 1 to 10 has been missed by the consumer. So you can see this inter-thread communication is very much important. When threads are not synchronized, even we have got synchronized method, but as I told you earlier, yes, a thread cannot call a synchronized method put on two threads, but you cannot stop another thread to call another synchronized method, which in this case is obviously the gate method. So you can see here all these values are missed, and 11 is being consumed for many times. You can see now because the consumer got the opportunity, so it ran for almost 20-30 times, and resultantly it consumed 11 many times. So you can see even these synchronized methods are not solving the problem. So when such is the situation in which multiple threads are calling different synchronized methods, and then we need a better mechanism of inter-thread communication. That's where Java provides you these three methods: wait, notify, and notify all. Now this wait method actually tells the calling thread to give up monitor and go to sleep until some other thread enters the same monitor and calls notify. It means that a thread can voluntarily wait for other threads to complete their execution. In that case, when you call wait on a particular thread, its execution will be suspended, and it will resume only when some other threads are going to notify it. It means that now, say for example, producer and consumer, if both of them are coordinating each other, then producer can ask the consumer to wait till it has produced a new value. Similarly, consumer can ask producer to wait till it has consumed new value. So in this way, their communication can be more systematic. Let's see the wait and notify version of the same program. This is PC fixed, in which again we have got queue. Here we have added one extra variable, which is value set, which is initially false. It means that value has not been set. Right. Now what we are doing here, we say inside the gate will be called by the consumer. We say while value set is equal to false, because if this is false, this is inverting it, so this will become true. So this loop will execute only if the value set equal to false. So we say while value is not set, try to wait. Right. We say in that case, because this is consumer, and if value is not set, consumer has to voluntarily wait because new value has not been set. So it actually continuously checks if a new value has been set. If a new value has not been set, it will go voluntarily in waiting state. Right. But eventually, if producer has produced a new value and if the value has been set, then you know that this will return true and loop will not execute, and it comes to this point where it actually then prints got in and then turns value set equal to false, because this indicates that we have already consumed the current value. So we now set value equal to false and then notify. When I notify, I mean that I have consumed latest value, and now I am notifying to the producer, the one which is actually waiting to call a synchronized method on queue, to please restart its work. Right. Similarly, if you see in the put, input, if we say value set, it means that if still consumer has not consumed the value, it means that it's the value set will actually be true. If the value set is true, we assume that the consumer has not consumed the latest value, so this actually goes into waiting state, because it knows that latest value which I have produced has not been consumed yet, so this goes into the waiting state, right? But eventually when value set equal to false, which actually consumer will do when it actually consumes the latest value, then this loop will not execute. This will come here. Here we say this dot n is equal to n is the new value that we have got from the caller, right? And then when we set new value, we set the value set equal to true, which actually kind of informs the consumer to consume the latest value, and then we simply write here what the latest value has been put. And then we notify because we know that when we are putting new value, consumer is waiting. So by calling notify, we actually stop the waiting state of another thread which is actually trying to work on this object of queue. So this way they are absolutely sure that if producer is producing some value, it is asking others to wait, and when consumer is consuming some value, it is asking others to wait. So this way no value will be missed. All the values that producer is producing will be consumed, and all the values which consumer is consuming will be consumed only by once, right? Again, you can see here we have got this producer class. We had this inside producer, same way we did in the previous example, producer queue, this dot q is equal to q, and then start run method, indefinitely putting the value, indefinitely consuming the value. Everything else is same as in the previous example, right? Now let us run this program. You will see that because of this wait and notify method, the execution of this program will be as per our expectation, that is to produce one value at a time, to consume one value at a time. So you can see I stop it, then when you see put 0 got 0, put 1 got 1, put 2 got 2, put 3 got 3, put 4 got 4, and so on. So you can see now these two threads are very much on good terms to each other. They are really having a next level synchronization, which actually ensures that nothing is being missed by the consumer, which is produced by the producer, right? Now this is the wait and notify method, which is used for inter-thread communication. We also have notify all. I mean, in case if more than one thread is waiting on the queue, then you don't need to call notify individually, but you can also call notify all, so that all the threads which are in the waiting state on this resource, on this queue, should be notified that a latest action has been performed, right? So this is the beautiful process of inter-thread communication by using wait and notify method. I stop this lecture here, and when I come back, we'll try to finish multi-threading. Thank you very much.